Hello everyone. Thank you for watching my seminar. My name is Sally Ross. I'm a graduate student at the University of Tennessee, Knoxville, in the Department of Forestry, Wildlife, and Fisheries. Today I will be sharing with you a research study that I conducted during the summer of 2015. The title of this research study is Utilizing Our Tree Streets as an Inventory and Assessment Tool at Oak Ridge National Laboratory. Today's presentation outline will go as follows. I will provide background information about my research site, justifications for this research objectives, methods, and proposed statistical analysis. My research area is located at Oak Ridge National Laboratory. ORNL is formerly known as the Clinton Laboratories, or X10. Today, it is the largest and most diverse research development institution in the DOE system. Its primary focuses are research, development, and national security. As such, it encompasses a wide range of land uses such as research facilities and utility infrastructure essential to fulfilling ORNL and DOE's mission. In an effort to improve ORNL's overall sustainability, stakeholders such as ORNL Landscaping Committee have incorporated sustainable landscape practices into their planning and management. Their overall goal is to guide future environmental resources and sustainable landscape practices at ORNL. Here are two pictures to illustrate the progress that has been made at ORNL. In the 1940s, the federal government obtained the land to build research facilities to support the World War II effort. Initially, the area was farmland or rural land and was quickly converted to what can be considered urban. Today, ORNL has a nicely landscaped campus. Multiple groups have worked to create a sustainable landscape that features native vegetation and other natural amenities. Here is my study area. My study area includes ORNL's Central Campus, which is approximately 450 acres. 3 other facilities also located on site. Those are HIFER, EGCR, and SNS. I assess trees along roads, sidewalks, and other landscaped areas. The justification for this research includes developing a working street tree inventory for ORNL's campus. Second, the data collected in this inventory will be used to make management decisions regarding natural resources present on campus. And lastly, information gathered in this inventory will be used to promote sustainable development and environmental conservation and increase public awareness of the values and benefits associated with trees. My objectives for this research are to 1. Determine the structure, function, and value of woody vegetation on ORNL's campus. 2. Quantify ecosystem services associated with this vegetation. 3. Identify hazardous trees, especially ash trees that have been infested with the emerald ash borer. For overall, all hazardous trees that may threaten roads, property, infrastructure, and/or public safety. Methods. The ORNL Street Tree Inventory locations included ORNL Main Campus, EGCR, HIFER, and SNS. The attributes collected in this inventory included the geocode, which is a unique ID number for each tree, and also the geographic location of each individual tree, species, those being native and non-native trees. In this inventory, I specifically assess trees with a DBH of 6 inches or greater, or those planted 10 or more years prior to the date of the inventory. I also assess the trees based on condition. Conditions were assessed from the ground and rated as good, fair, poor, or dead. I also identified management requirements and gave recommendations for each individual trees. In this inventory, I also identified hazardous trees that may damage infrastructure or property. I documented these trees by their structural defect, disease, or pest infestation, and potential targets such as parking lots, buildings, or picnic tables. In this inventory, the tools I use in this inventory include the Geo Explorer 6000 series GPS to collect and store data, a Pathfinder software for post-processing, Map Info Pro to create maps and represent the data, Google Earth, and iTree Street software to analyze inventory data. Here is a map of ORNL Central Campus broken down by block number. Blocks were used to facilitate the inventory. Trees were documented according to their block and building number. Here is a map of the completed inventory. This map shows the distribution of trees throughout ORNL's campus. Here's an example of the inventory data sheet and also a map of the location of hazardous trees on ORNL's Central Campus and surrounding facilities. I utilize the iTree software to analyze inventory data. iTree is a software suite developed by researchers at the USDA Forest Service to provide urban forestry analysis and benefits assessment. This software is used nationwide by industry professionals and researchers. Although this software is free and available to the public, it can also be used to measure tree benefits, trees in your backyard, local parks, or in neighborhoods. I utilized a specific application within iTree software called iTree Streets. iTree Streets uses Stratum, which incorporates tree growth and benefit models, along with local, hourly air pollution and weather data to calculate the structure, function, value, and management needs. The structure includes diversity indices, and it uses the Shannon Diversity Index to calculate it. Species, condition, and structural value. The structure value is estimated based on the CTLA formula, the Council of Tree and Landscape Appraisals. The function of these trees are estimated, including the pollution removal, such as ozone, sulfur dioxide, nitrogen dioxide, carbon monoxide, and particulate matter. Also, annual carbon sequestration and avoided runoff benefits. Stratum also estimates the economic value of the ecosystem services provided by these trees. It also identifies management needs, such as improvements in canopy cover, planting, pruning, and removal needs. So what we learn from iTree Streets is, do the occurred benefits outweigh their management costs? If you would like to learn more about iTree, please visit the website listed below. Here are some results. Here are some results generated by iTree. ORNL has approximately 652 trees of 54 species. The top 5 species are pin oak, eastern white pine, American sycamore, black locust, and eastern red cedar. Combined, these trees make up 47% of the street tree population. Pin oak has the highest importance value of 16.6. Thus, ORNL's urban forest is most reliant upon this species because of its current size and abundance. Based on data generated by iTree Streets, here are some annual benefits. Each tree provides an average of $99 worth of benefits annually. Collectively, these trees provide $64,000 worth of in environmental services and aesthetic benefits annually. These trees are estimated to sequester a total of 265,000 pounds of CO2 annually. They also are estimated to intercept 2.3 million gallons of rainfall annually, which is beneficial in stormwater mitigation. The structure value is also estimated to be $3.4 million. Here's some examples of results generated by iTree. As mentioned, of the structural value, pin oak and willow oak has the highest structural value. Both are valued over 440,000 in terms of its population on campus. Also, pin oak and eastern white pine are most beneficial in stormwater mitigation, as they both intercept large amounts of rainfall annually. Again, this data was interpreted based on energy benefits, air quality, stormwater reduction, carbon dioxide use, and aesthetic values, which were estimated by iTree Streets. Last is proposed statistical analysis. I must mention that analysis necessary for this particular research project was provided by iTree Streets. Although I will use R software to do further analysis, the analysis that I will conduct is the mean DBH. The mean DBH of trees in this inventory is 16.87. The mean height, that value is 39.78 feet. I will also conduct a pair t-test in R. A pair t-test will compare the size of pin oaks in high impact versus low impact areas. I chose pin oaks because it is the most abundant species on campus, and it's the largest in terms of its diameter and height. The pair t-test will determine if activity in high impact areas or low impact areas has an impact on tree size or growth. High impact activities include such as high in physical disturbance, such as construction, compaction, or high vehicular traffic. Low impact areas are areas that include plazas, quads, and open areas where trees are not likely to endure physical disturbances. From there, I will compare the differences in the two means to determine if activities have an impact on the tree size and growth. Thank you for watching my seminar. I hope that you enjoyed it and learned something valuable. If you have any questions, please email me. And remember to remain friends of the urban forest and keep our community clean and green. Thank you.